Alright guys, this is just to show you how you could deduce the Young modulus of elasticity of a rigid body, and to do that we'll be needing a cantilever. In this case, I'm using a meter rule, a 1 meter rule that is clamped using a G clamp on a bench. Of course, you know that this system represents a cantilever, just a rigid support that is balanced horizontally, supported at one end. In this case, I'm using a G clamp to clip the meter rule to create what my cantilever. Now, I have also another meter rule here that is supported by a retort stand standing vertically. Now the cantilever is horizontal, and now I have a meter rule also standing erect or vertically, supported by a retort stand. And also to do this, I have a pin. You could balance it either ways. You can actually do that here, or you could do it at the tip, anywhere, depending on the instruction. It depends on the examiner. The examiner will tell you what he wants you to do. But in this case, I'm using any point along the horizontal meter rule. So if it is going to be this form, the examiner will tell you at which point to actually put your pin using a plasticine. Right? I feel more comfortable with a tip, and for this particular demonstration I'm using point number 55. I'm using the 55 cm mark on the horizontal meter rule. I attached my pin at the 55 cm mark of the horizontal meter rule. Now, if you're going to be writing any particular exam, the examiner will tell you to put it at any particular point. So you do follow the instruction that the examiner is going to be giving you. However, if the instruction also comes that you should put it at the tip or at the extreme or at the 100 cm mark of the meter rule, that's fine. That means that the position of this meter rule now, this particular meter rule that is vertically standing, will now be somewhere here, such that the pointer can actually point towards the vertical meter rule. In that way, we could be able to find the depression of the meter rule. That is to say, whenever we use sets of masses, in this case, I'm going to be using 50 gram masses. Here, a 50 gram hanger, and then other 4 50 gram masses. So, and then a thread. The position of the hanger is going to be communicated to you by the examiner. But for this particular demonstration, I'm using 25 cm from this side. I'm using 25 cm from this end. So the examiner will tell you at which point. So it's at point 75 here. The examiner will also tell you at which point to hang the load. Also, from this point, I hung the meter rule at 90 cm mark. So it means that here is 10. So from 10, the allowance I have, the length of the meter rule from the point of the clip to the end is 90 cm. So now it is firm. For me to now get the depression, I'll have to hang in a mass of 50 gram. Before I'll do that, I'll have to first of all take notes of the initial pointer reading. The initial pointer reading at this point, and I'll record it maybe using X0, or if the examiner says you should record it using Y or any other value, you can follow the instruction. But this I will use X0. Now, if I try to use or apply all necessary precaution, I'll read this off using eye level, which we refer to as parallax, avoiding parallax error. So if I avoid parallax error in reading this, my value is going to give me 47.5. So it means that my initial pointer reading is 47.5. So now that I've gotten my initial pointer reading, the next is for me to hang in my 50 gram mass and find the depression that is going to bring. Okay, here is the mass, 50 gram mass hung at that particular point. Now let us find out the depression from the original point. Now, avoiding parallax error, you could see that the pointer is at point 48.5 48.4 rather, 48.4. So I'll record that under 50. Hence, to calculate the depression means that I'm going to find the difference between this particular value and the original pointer value, but that will be done at the end of the experiment. So I'll continue to put in the 50 gram masses, and then I'll also record the pointer readings at each particular level. Let me quickly do that, and then I'll show you what the table will look like. All right, now having inserted the another 50 gram mass, I have a total of 100 gram, and then to find the pointer reading, I'd have 49.3. Ensure that the meter roll is not bouncing, or avoid draft as you're conducting this experiment or a windy environment. So 49.3, that is the pointer reading at 100 gram. Now I have the third one, the 50 gram mass, that's making it a total of 150 grams. The pointer is at point 50.2. And as I begin to wrap up, this is the fourth one, that is making it a total of 200 grams. And then the pointer reading is at point 51.1. And then finally, having a total of 250 grams, the pointer reading is at 52.2. That's what I have here, 52.2. So this is what it looks like at the moment. Having inserted all the masses, I have a total of 250 grams, and this is what I have at the moment. But to ensure that the elastic limit has not been exceeded, I will also unload and then find the average of the depression. I'll find the average and then use it as my value, so that to ensure that the material has not exceeded its elastic limit. So I'm going to unload and also record, and then I'll find the average at the end. All right, now I've unloaded one of them, so I have 4 now, that's 200. Unloading, to check my value, I have 51.5 is as against 51.1 initially recorded. I've removed another one, making it a remainder of 150 grams, and then my value or my pointer is at point 50.6. That's what I have here, 50.6 as against 50.20. All right, now I've removed another one, so we have only 100 gram mass remaining, and the pointer is at point 49.6 as against 49.30. And finally, the last one, which is the 50 gram mass. Now I have my pointer at the 48.7 point, 48.7. All right, so this is the summary of what I have: the mass, the X loading, and the X unloading, and then the average, then the depression. The depression is simply, I simply found the average of the X, and then the value I got there, I subtracted it from the original pointer reading, the X naught on top of the table, and that gave me the depression D. Now you could also use this table now and then plot a graph, especially a graph of M against D, or D against M, depending on what your examiner wants from you. Or they could ask you some other things, maybe to evaluate some other things as a result of what they intend to test you on. Or majorly, you could use these values and then plot a graph, and of course deduce the Young modulus of elasticity of a rigid material, just like the meter room. So theoretically, you could use this formula: D is equal to mg L cubed all over 3IE to deduce the depression of the cantilever, where L, E, I, D, and Mg are all stated above. Now remember to follow the precautions, and of course you could read up more on elastic properties of solid for sub-questions that may arise as a result of the topic, which could also be asked you during any form of exam that you're going to be encountering as a result of it. I believe it has been very helpful. You could write us and tell us about your complaints or whatever that you need, clarification that you need. Thank you. I appreciate it.